In this video, we are going to cover the chapter of polynomials and partial fractions, focusing on the skill of how do we apply and use the remainder theorem, and how do we use and apply the factor theorem. So let's start by looking at the remainder theorem first. Okay, this is extracted from the notes. Let's look at recall what is the remainder theorem. The remainder theorem states, when a polynomial fx is divided by a linear divisor. So very important, when I see linear divisor, you need to understand that linear, let me highlight this, linear divisor. It means that the degree of your divisor, is equal to 1. Okay, so over here, any linear divisor can be represented in this general form, ax minus b, whereby a and b are just constants. So if I want to find the remainder, I just simply need to sub x to be equals to b over a. And if the divisor is simply x minus a, I just need to sub x to be equals to a. So let's see how do we apply this remainder theorem into polynomials. So let's look at example 1. Okay, example 1 states, if I'm given this polynomial here, x cubed minus 4x squared plus 3x plus 1, how do I find the remainder? So if I divide this by this divisor here, so very simple tip, when I see a divisor, how do I know what x value to sub in to use the remainder theorem? Simply, you can do a small working at the side. If this over here, this is my divisor, okay, what I can do is that, so to find what x value to sub in, I'll just let this divisor 2x plus 1 be equals to 0. Then from there I solve for x will be negative half. So therefore, this value of x will be what I need to sub into the original polynomial here in order to find out what is the remainder. Okay, so the proof of this can be found in the notes, but going back to applying the remainder theorem itself, so therefore for this question is simply sub x equals negative half into fx. So therefore, what I'll do is that I'll simply replace my x to be equals to negative half. So this is very important to equate this to be equals to 0. If not, a lot of students will get confused and will miss out this negative sign here, which is very, very important. Okay, so from here, if I sub x goes to negative half, I simply replace all my x values here, x unknowns from the polynomial with negative half. So this will become negative half cubed minus 4 times negative half square plus 3 times negative half plus 1. Okay, so from here you just need to simply key this whole expression into your calculator, and therefore you should be very easily be able to obtain what is the remainder for this polynomial when I divide by the divisor of 2x plus 1. And you notice that if I key this into my calculator, I should get the value of negative 13 over 8. Okay, so therefore I can conclude this question. Therefore, by remainder theorem, okay, by the remainder theorem, fx has a remainder of negative 13 over 8 when divided by the linear divisor which is 2x plus 1. Okay, so to wrap up, just remember that the remainder theorem only works when I'm looking at the linear divisor whereby the power of x is equal to 1. Okay, so let's move on to the next one, the factor theorem. How do we use and apply the factor theorem? Let's read the factor theorem first. So actually the factor theorem here, one very important thing is that it's actually just a special case of the remainder theorem. So what this means is that the factor theorem is a theorem that happens when I sub a value of x into my fx, and somehow my remainder here becomes 0. And when the remainder becomes 0, this is when the factor theorem comes in. If the remainder is equals to 0, okay, this x, our linear factor here, is a factor of fx. And I can also say that the fx, the original polynomial, is divisible by the linear factor that I am dividing this fx by. Okay, so let's look at one very simple example. Let's say example 2. Show that x minus 2 is a factor of gx, and gx is defined by this polynomial over here. So what I simply need to do is that if I want to show that x minus 2 is a factor, I do a very simple equation. Over here, I let x minus 2 be equals to 0. Then therefore, I know that I need to use the value of x equals to 2. So what I'll do is that, to show that x minus 2 is a factor, first I find what is the remainder first. So the remainder, when I divide gx by x minus 2 is that, I'll write sub x equals to 2 into gx. So very simply by working, this will be g times 2 is equal to 2 times 2 cubed minus away 4 times 2 square plus 2 minus 2. Okay, then from here you notice that over here, this is actually 16 minus away 16 plus 2 minus 2. And if I simplify out and if I evaluate out using your calculator, you'll get 0. So now remainder is 0. I can now use the factor theorem. Factor theorem states that if the remainder is 0, then this linear divisor here is a factor of whatever polynomial I'm dividing it by. So therefore, since I've seen that the remainder here is equal to 0, therefore, by factor theorem, okay, I can conclude that x minus 2 is a factor of gx. And it is very important for you to state by factor theorem, because you are telling whoever is marking your work is that you know it is because of the factor theorem that x minus 2 is a factor of gx. If you just write from here, then you get to this part over here without stating this, it may not be very clear on how you know that because remainder is 0, therefore this linear divisor here is a factor. So very important, please make sure you state whatever theorems that you are using either by factor theorem or by remainder theorem to make your working clear to whoever is marking your work. Okay, so that's the end for this video on how to reuse the factor theorem as well as the remainder theorem.